Hello everyone and welcome back to the channel. I have some fantastic news, and that is that we've reached 500 subscribers. 501 right now, but hopefully it will grow a little bit after I publish this video as well. So thank you very much, all of you, for just subscribing and joining me. I hope you're all doing well. I'm unfortunately just very slightly unwell, a little bit nasally, with a blocked nose and some headaches, but I think we can power through this video as well, which will be a nice and relaxing one anyway. Right, so today we're going to finally talk on the last gas giant, which is Saturn. It has been a long while since the Jupiter socks that we made, but I had these socks on the needle for ages now, just waiting for an opportunity to make a video, and yet I never did it. Today's going to be a fairly short video, mainly because I'm quite ill and I can't talk too much without without my voice sounding very nasally, which is very, very fun. So let's just crack on with it. I'm at the final bit of the last sock. I'm on the heel, as with pretty much all the other socks, now that I've finally finally learned how to knit on camera. So we're just going to do the heel, which is just a bunch of decreases in each row at the edges, and then you make the toe by casting off and sewing around it, just like before. If you're sewing or if you're knitting something, feel free to just bring that along and join me whilst I talk about Saturn. So Saturn is still pretty large, although not as large as Jupiter. Its radius is about 57,000 kilometers, making it about 760 times larger than Earth, which is still ginormous if you ask me, but not as big as Jupiter's 1,000 times larger than Earth size, which is mind-bogglingly huge. It orbits fairly circularly around the Sun, and it takes around 30 years to actually make one Cronian year. So I'm not actually one yet on Saturn, which is quite interesting. Its day is around 10 hours and 30 minutes, which is still much smaller compared to Earth's. But if you remember in our last video, we talked about conservation of angular momentum and how likely the planet's formation may have played a role in this short day. Whereby when it pulled a load of stuff in and accumulated loads of gas, helium and hydrogen, for example, it would have increased its rotation in order to conserve angular momentum, causing it to have a much shorter day than perhaps Earth, Venus, Mars, definitely Venus. Saturn is probably the least dense planet that we have, because it is, a gas giant. It is very lightweight in a way. And actually the gravitational constant, so our gravitational constant is 9.81 meters per second squared. Saturn's is only just very slightly larger at 10.44, and even though those numbers are quite similar, you will definitely feel the difference. I mean, first of all, you'll be dead if you try and actually enter Saturn. Saturn also has a huge amount of moons. For as far as I can remember, it had at least 62, although I believe we have discovered quite a few more. We'll be talking a little bit about some of these moons in more detail later. Saturn, like Jupiter, is a gas giant. Its dominant elements are hydrogen and helium, the two lightest elements that we know of, and it also has a very high pressure and high temperature, meaning that a lot of the hydrogen and helium that we know traditionally as gases are actually more fluid-like and can become liquids. So as we know, liquids and gases also, they're fluids essentially, they have very similar behaviour. But one thing that we do hypothesize, we don't know for sure, but that we hypothesize, is that this liquid may also be in the form of droplets, or as we know it, rain, which is quite interesting. Once we get more towards the atmosphere, the upper layers of Saturn, this is where we pretty much just get gaseous hydrogen and helium plus some other elements. We also see quite a lot of wispy streaks in Saturn and a lot of jet streams. These often reach way over 5 times Earth's wind speeds, which is staggeringly fast. One of my favourite features, and actually I think this is my favourite feature of all, is the hexagonal jet stream that we have at the North Pole of Saturn. This jet stream, it lies at the North Pole of Saturn. It's about 2.4 times wider than Earth, which really makes us feel very small. and the middle of it is a polar vortex. Now, usually on Earth, these disperse quite quickly and they're usually in the Earth's ocean, but not on Saturn apparently. A team of researchers led by Dr. Ana Aguiar managed to actually recreate something very similar to this hexagonal jet stream in a lab on a very small scale. So there is some promising evidence that we may fully understand this very soon, but essentially the leading theory is that it's a planetary wave that's essentially interacting with itself 6 times to create the hexagon. It's quite confusing to me. I'm not very good at waves, but honestly, it just sounds pretty amazing that you could even just get hexagons in space. Now let's move on to the people's favourite, usually, and that is Saturn's rings. When Galileo first observed Saturn, he actually had no clue what he was looking at. His telescope wouldn't have been powerful enough to actually understand that it's quite clearly rings he was looking at. But it was actually Christian Huygens that first proposed that Saturn had rings. Unfortunately, our ability to actually see the rings greatly determines our knowledge of them, and so the naming system for the rings is quite interesting. So when you look at the rings, you can see that there's quite thick, like a really thick disc, but what you don't know is that there are many more rings actually outside. So within the thick rings, we start off from A and go on to D, being the closest to Saturn itself. And then we actually have some outer rings which are slightly softer. These are called E, G, and F, and I know that's not in order. Like I said, our knowledge of it is greatly determined by how much we can see. Some of these rings, particularly the C ring and I believe the A ring, are split up with some gaps, notably the Colombo gap and also the Encke gap. This is quite important, even though technically there's meant to be nothing there, because there are actually moons within these gaps and some rather interesting features. Okay, I think I've only got 2 more rows left and then we're done. These rings are made up typically of rocky material and icy material, typical stuff that you'll see within the solar system. These can range from a couple meters wide, very small items, to houses wide essentially, and I know house isn't an SI unit, but we've already added washing machines to the units, and so with your help I think we can add houses to the units as well. Some of the actual gaps within the rings, so the Colombo and the Encke gap, have actually got moons inside them. So for example, we've got Pan in the Encke gap, and we've also got Daphnis, which is in the Keeler gap. And what's really cool about Daphnis is that it actually, because it's quite large, it can have a gravitational effect on the edges of the rings, you know, where it's close to the moon. And so what you get are ripples and tugs as Daphnis is moving along the rings, and that's really cool. Also, Saturn also has moonlets, which are distinctly larger than the rings, one of them being Santos Dumont. I think I've finished. Just need to sew things up. I'll just check the other sock because I cannot remember what I did. I'll just get some needles and sew this thing up, and we can talk a little bit about observing Saturn. So viewing Saturn through a telescope is just a tad bit more difficult than Jupiter, mainly because it's so far away. However, its rings are just absolutely beautiful, and regardless of what telescope you have, honestly, it's well worth just trying and having a look. I think my first viewing was of Saturn, and it got me hooked onto observational astronomy for life, I guess. It was so beautiful. With the less powerful telescopes, you probably will at least be able to see a disk. You might not be able to see too many gaps or any gaps at all, and the planet in the rings may sort of mush itself together, not be so easily distinguishable. But with a more powerful telescope, you probably will be able to at least tell the difference between the two. One of the reasons that I think people should love Saturn is that it's extremely rare. Just in terms of planetary physics in general, to have a Saturn-like planet of that size is super rare, even in exoplanet surveys. It just shows that our solar system are unique, and not just Saturn, of course. Earth is also quite unique to have an Earth-sized planet, and also I believe it's either between Jupiter and Neptune. One of those are really rare as well, but you know, we are so unique compared to other exoplanets and exosolar systems, and it's just fantastic. Just going through a second time round with the yarn to make it much tighter. Damn, this one looks so much better. Oh my goodness. Oh my goodness, this looks so much better than the first sock. Oops. Never mind, nobody will notice. Turn it inside out, weave in those ends, and we're going to be done. When I weave in ends, I know you probably won't care about this, but I usually weave it in down the pearls one way and then come up the other way. It actually forms a much stronger tail end that doesn't unravel. And oh, my yarn came out. But yeah, it just does, and I'm quite scared about yarn unraveling and getting ruined. Although I never put things in the washing machine, I never tumble dry things. I don't see why I'm so scared. There we go. Turn that inside out. And what would you look at that? One beautiful satin sock. Yeah, you can, it does kind of feel like the rings in a way, because you've got all the stripes and it feels like rings and gaps and icy material and rocky material. That's quite cool. I only just realised that. But yeah, you've got some really beautiful tans, some whites, a bit like the wisps that you see in satin, and of course the purples, which you can see near the North Pole in some images, which is really cool. And I'm really pleased with that. I've also got the second sock over here, which, yes, they're definitely not symmetrical, which is, they're not identical, which is pretty nice as well. I do like a little bit of handmadeness, you know, to pop out into my hand knitted garments, which obviously they're handmade, but it's quite nice to see that. There we go. I'm really proud of these. Also, speaking of handmade items, do you like my my vest? I knitted it myself. The pile of planetary socks are now is very large now. Oh, these are really cool. I'm really proud of what I'm doing. Every time I add a new sock onto this, I just feel like it's just getting better and better. Thank you very much for joining me. Yeah, if you stuck around, if you knitted something, just let me know. I mean, just comment how you are, I guess. It's nice to talk with people who share the same interests in me. Also, once again, thank you very much for 500 subscribers. Between the Uranus, Neptune, and of course Pluto socks, we can't forget Pluto, I will be doing a lot more cosmology vids, maybe some more mathematical based ones, very, very simple maths, by the way. But yeah, that is basically the subject that I really love, which is cosmology. The next one probably will be on inflation, which is a rather interesting theory. Maybe not theory, maybe a truth. We'll never know. But yes, thank you very much for joining me, and with that, I'll see you soon.